how do you actually implement or consider implementing AI within real life situations. And we're going to start with this Google paper. And then what we're going to do is we're going to go ahead and actually introduce 3 of the recent articles and then discuss one by one what we're talking about. Physician-centered oversight. And that is the core issue that we are thinking, that how we use AI in a way that is actually produces value and does not produce, other issues in terms of, hallucinations, and ensure that it is providing proper value. So within this paper, we said that the PCP provides oversight, retains accountability of the clinical decision. And then, of course, we compared GMI to NPs and PH group of PCPs under the same guardrails. So that's the real benefit of this particular guardrail system, and then how it is actually implemented in their lives. Before we start, let's talk about guardrails in AI. And then there are different ways to do the user experience, but I want Harvey to introduce that subject so that everyone understands what guardrails mean.
When it comes to guardrails, what exactly does that mean? Think of it this way. You're having a conversation with someone. Today, you're speaking to a high school student. Maybe you're speaking to someone that's a little bit further along. The AI has different mindsets, different IQ levels. Now, what does it mean to have a guardrail? Well, if you're speaking to, let's say, Albert Einstein, and you wanted to build a bomb, you could literally ask him and he would tell you, yeah, these are the things that you need and this is how it's done. But that's dangerous, right? We don't want people to have access. So AIs are being able to be built in such a way that if you ask certain things, it guards against that. And then they can create parameters. In fact, when ChatGPT first came out, they were really good about anytime you ask for medical advice or anything legal, it sounded like a lawyer, like this is not doctor advice, blah, 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 disclaimers. And so there was different guardrails set up for that. Now, as we progress with the different large language models, we're starting to see those guardrails shift and change. Why? Because they know that the user behind it, more than likely it's going to be a doctor. And so that automatically starts taking off those guardrails. On an aside, some of these open source models, they have been created and people have manipulated them to the point where they take off the guardrails. And sorry to go off track a little bit, but when you look at Grok, one of the things about it is they have also taken some of the guardrails off to a certain degree. And that's why you're able to ask Grok certain questions that you cannot ask ChatGPT.
You're absolutely right. So one of the things that, building large language models or AI in healthcare, and specifically healthcare, the first is definitionally what is, we're building. But for example, AI can write a blog post or produce an image that you're going to share on Facebook, LinkedIn, etc. It's fantastic. It's amazing. It saves a load of time. But then that is called what we call low stakes AI. In terms of implementation. Then we have what we call medium stakes AI. Medium stakes AI is that you are actually using it in your enterprise, in your business solutions, etc. For example, AI is helping you calculate or lead generation or lead qualifications, etc. And there's a bunch of leads coming, and then you say, okay, this lead is very important, etc. That is called what we call low to mid stake AI. Then we go to one step further, in which, for example, you're using AI for your financial analysis and decisions. For example, a bunch of data comes in, and then you use machine learning, not truly AI, to analyze that data and then produce insights. That's sort of, mid to high. And then we have the true high stakes AI. The true high stakes AI is essentially 2 objectives. One of them is what we call medical, which we go in because lives matter. And if AI makes a mistake, you can actually potentially kill a person. And then of course, the second biggest one, high stakes AI, is what Harvey appropriately suggests is bombs. Essentially, it's military. So within the military complex, when you are establishing AI, that is what we consider high stakes, military and health. Now we come to high stakes AI. When you have high stakes AI, what you want to build from any workflow perspective is 2 things. One is that AI has an internal Guardrails. The definition of guardrails is that when you build these systems from a technical perspective, that an output is generated. That output is then checked against guardrails, that it doesn't say, for example, you're talking just guardrails. Very simply is that you can use a chat box that I have created with my backend. Again, it's a frontier model. You can write a blog too. So the first step is that, okay, you're not even asking a stupid question. Then, of course, all the BS that goes around the world on the internet from, you know, uh, crap. I don't want to use even those words here. What I'm saying is that we don't have those kind of things added into the system, or somebody's abusing the system for that. And then the last one, and the most important one, is that there's a recursive checking consistently of the output that is generated from the primary output. For example, we use the word verifier, the word. So we have another LLM that is constantly verifying the output from the first LLM and constantly checking it. So that's the guardrails. And it is so extremely, amazingly important for, again, healthcare AI and military AI, because those are very high stakes AI solutions that we have. The second question over here is your input on, Harvey. How do you implement it in real life? One thing is to have guardrails. Excellent. But what we need to do is concentrate, of course, within this podcast, is to bring these important insights so that people understand that if you're choosing a vendor, or if you're implementing it yourself, or you're experimenting, you need to know, most importantly, one thing is to build it. The other thing is to implement it. So if you want to go into, AI oversight paradigm via clinical, and this is the word asynchronous, then there's a multi-agent system. So you want to go into those details?
Asynchronous basically is it's not in sync, meaning if you're my patient, you ask me for medication, I need to help you, but it's in the middle of the night and you send me an email, my AI would look at what you're asking me, create a response. And then the reason it's asynchronous is this morning I would wake up, I would look at the response and say, yep, thumbs up, and then it would send it forward. That's why it's called asynchronous. Now, what's really interesting about how they created this next part, the multi-agent system, think of it this way. An agent is just like a helper of mine. So we have one agent that is going to look at the diagram of that question and create a response, and it can respond, and inadvertently it may give a treatment plan. But then the second agent, this is where the guardrails come in, and I think this was genius. It goes through and looks at that first response, reads it, and say, whoa. This part is giving the medication. Yes, I'll give it, but it's now it's started to talk about treatment plans, and we don't get treatment plans. So now it'll literally take it away and give me the response that I need, which is really good, because now as a provider, as a physician, now I don't have to go through and be like, oh, I really can't say this or not. It's pretty much set. And the other part of it is I can give a treatment plan, but if I have my nurse or someone else that doesn't have that authority in a way, then the guardrail is there, and then the nurse can push it instead of me pushing it to the patient.
So you talked about two important, amazing use cases. And this is something that happens so much clinically. I mean, you have been an ED physician all the time. I've been an ICU stroke physicians. And believe it or not, when you are implementing it in a multi-site system, let's say if I'm sitting here at a quaternary center with director of neuro ICU, director of stroke, there's actually a 100-bed hospital. This is now primary care stroke center. And over there, even the physicians, not just nurse practitioners or PAs, have very low experience. I mean, they actually see 2 stroke patients a month max, as compared to me seeing literally 300 stroke patients a month. So the idea is that you're absolutely right, that when we have to do this, we have to start with, clinical dialogue without medical advice. So this is something that we actually see that. And then you can see that it can actually go into these agents. So PCP and PA are actually making their SOAP node, while more importantly, there's a guardrail agent that is consistently taking this collection, and then they see, over that. And then what they do is that within that SOAP node, there's a clinical cockpit, and the cockpit again looks exactly like what we're talking about. The clinician cockpit is that there's a dialogue transcript, subjective regular assessment, patient message follow-up, and then they select A and B. Again, what they are doing is a second guardrail. That second guardrail is essentially a human in loop. There is HIP And that's another, there are different terms that people have used. Again, there are people who use different terms as well. So the idea is that we actually go ahead and look at this into a performative way, that GAMI outperforms general PCPs and general NPs. So they compared this into the system, and what they realized is that they were, this particular guardrail system with asynchronous oversight is amazing in terms of implementation as far as in real world is concerned. So that's exactly what Dr. Castro was saying, that how we should know that SOAP notes and asynchronous oversights is concerned. One of the key ways that this guardrail was done, again, we don't want to go into too much detail. They actually have, I just want to make sure, dialogue phase transition. So they have done at every phase, generate response, and then there's medical advice. If there is medical advice, revise through the human in loop system. So I love this system. Honestly, I think there's three different approaches. So let's just talk about the second approach that is done by. So this was Google's approach. Now let's just go talk about OpenAI's approach. So this is interesting that, again, as I said, people have different approaches on how they have done. So this is the AI-based clinical decision support. Same thing, but they have restricted to primary care. And again, we discussed this in one of those meetings, one of the ideas. So this is their system as well. So what they have done it is AI-based clinical decision support, and this is a real world study, by the way, and they have done it on 22,000 clinical visits. So interesting. Yeah. So one of the things is, like, when you look at this initial documentation, blood loss appearance absent, parasite no, etc. Crystals, metronidazole supplement 3 times a day contribute to AI consultant response. And they are saying that the treatment involves metronidazole, which is not an indication for uncomplicated gastroenteritis. So this is exactly where AI consultant comes in. Now, this is really interesting and actually scary, because what he's saying is that for primary care, what did they do? They actually added a GI consult. And that GI consult is going to be a super specialist that is going to be available, and that is going to say, you know what, you don't need metronidazole. You just need zinc and you just need ORS. That's it. Saving time, saving costs, saving potential risk, side effects of the medication, and most importantly, evaluating for this. And again, think of this particular thing is that you will not have problems with utilization review and getting reimbursement from the, that is what is called from insurance agents. Okay. And this is the third approach. And the third approach is that is from Microsoft. And they said that sequential diagnosis with large language models. And then they did, a whole sort of medical orchestration. And what they did was that to improve, overall output, decrease the hallucination, what they did was that their design technical framework was to make an orchestrator and then create multiple different agents below it. And then all of that agents are super specialized and have their own guardrail. And therefore, think of it that, a pharmacist is there. Think of it as a occupational therapist is there while you're doing a PCP, or a cardiologist or a neurologist. And the idea is that you have created multiple amazing agents. And this way you actually progressively take that input and then slowly combine that into one diagnostic. But again, this is only related to diagnosis rather than giving a complete sort of picture in terms of treatment and management, which is different from the OpenAI approach and, of course, the Google approach. Again, we want everyone in the world through this podcast understand that, hey, how healthcare AI is extremely important, how it is very challenging to put it into production, and then making sure that if you choose a vendor or production, you need to understand if they have tested. And that's why what we're doing is we're building, we're experimenting. And as a matter of fact, that's what I say. One of the big things that, the big AI gurus say is that benchmarks are garbage. What you all need to know is that how many evaluations you have done. So believe it or not, we have 1,000 patient data set. We have all these, physicians' histories, etc., patient histories done. We actually constantly check, our models against our data set when it's deployed. This is my first thing when I actually deploy it. And then once this is done, it is going to be moving forward.
Let me add some information. So for people listening, he mentioned some interesting things. There's something called data drift. Let me explain that. When you create AI and you have a certain model, today it's doing what I need. But with time that passes, that model starts changing because the way I ask the questions, the way I reinforce it. And then with time, if someone's not watching the model, it drifts. And what does that mean? Well, if today it's having me do, let's say, this consult, but with time, it starts morphing, and it stops doing the intended goal, then it has drifted. And so for you guys that are implementing AI into your system, make sure that you either have some kind of chief AI officer in the company that knows about these things so that they can look out. And then more importantly, when you sign that contract with your provider that you're having come in for your AI, make sure you cover this. Is anyone maintaining the data drift? Is there something going on? Who is doing that? What parameters?
So the goal of today of understanding all these things was and showing you in this idea, and that's why I do look at all this research on a consistent basis, is to understand that for you guys, again, is to understand that AI in healthcare is extremely high stakes. You have to test all the time. And then validate. Think about guardrails on every single step. And then implement it in a way that Harvey suggested, that it is not disruptive to your system, but rather providing true, clear value.
And I want to add one more thing. We talked about this in one of the other episodes, but it takes a village. When we're creating this, make sure that we're including our patients. Make sure that we're including the front line. You know, it's a lot of times, for example, I'm consulting hospital systems and they're like, hey, Dr. Castro, we want to do X, Y, Z. We already bought the system. We want to help have you come in and implement. And I'm like, whoa. Did we talk to the front lines? Did we talk to the patients? Did we have them in part of the system? Because from a cultural point of view, maybe the doctors, nurses, and all say, whoa, we don't need that fix. And that workflow is horrible. This is going to make it slower for us and we don't want it. And so I want to stress that again today. We got to make sure that everybody's in line, that everybody's on the same page, that we're moving forward together. Because think about it, if a C-suite spends millions of dollars and all commits and it's the wrong problem. The other thing I want to just add a little light to is nobody talks about the electric bill. And you're like, what? Electric bill? Yes, these models take a lot of energy. And so if we start adding models, and the way we're using it, it might end up being another line item that we hadn't thought of. So I just wanted to plant that seed.